Okay, today we will talk about the co-channel interference in the GSM. Co-channel interference in GSM. So what is a co-channel? As you know that in the GSM we have to reuse the same frequency at a certain distance because we have a limitation of the frequency, right? So you are using F1 frequency here. At maybe certain distance you have to use the same frequency, and it may happen that frequency is interfering each other at certain distance or at certain location, and they creating the interference. Now, as per the GSM specification, we supposed to maintain the co-channel interference, that is in, we call it as in dB, should be 9 dB for in case of if you have a hopping network. It may be RF hopping or in a basement hopping. We'll talk about more in the RF hopping and the basement hopping. And should be 12 dB if it is a fixed frequency or BCCH layer, because BCCH is carrying the major signaling, and should be clean as much as possible. Or if you use the fixed frequency, then there's no advantage of the hopping to reduce your averaging and all, so you should keep this for the fixed frequency also is a better one. So this is what we are looking for. We call it as a C by I. So here in my case, if I'm here somewhere in this distance, then let us give this cell name is B and this cell name is A, and my frequency F1 of A is divided by frequency F1 for B, which is my interference, because I am very close to the A and I am currently connected with the A. So this difference has to be, let's say in the safer side is 12 dB, right? Now in this case you can see how it works. So for example, if I get this the Rx level from the cell A is for example is NIC 80 dBm, and if my interference is coming, which is let's say NIC 92 dBm, so they are in ratio of the dB, so I can easily minus them. NIC 80 minus NIC 92, so that comes around 12 dB. So I am safe in this location. Okay, so in this location I am safe. But let's say for example, if I go away from the cell site and now somewhere here, if I am standing here now, so in this case what will happen? So let us try to calculate the C by I here. So the C by I here, let us assume that now I am getting signal strength of the A is around 90 and the B is coming around 98. Now the difference of this is 8 dB. So in this case I could not able to decode the signal from the A, because the B is quite strong and it is creating the interference. So this is very much important to keep this difference is 12 dB, by. And how you can do that means, for that you need to ensure that the B should not come very stronger to the A as long as it is possible. Okay, and to give you the understanding on the chart, this is the let me draw one idea for you. So this is, let's say for example, Rx level, and as the maximum what you can measure is minus 47, and the minimum is 110 dBm. So where exactly is your C, and where is your I? This is most important to understand. Let's say in our example was a 90 and I was 98, so this gap is not enough to decode the basic. So now what happened that if you connect it with the cell A is your, let's say, your serving cell, and cell B is your interference, right? So your what will happen if you have a co-channel interference? Co-channel interference will come, your bit error rate will go up, the FER will go up. So bit error rate means your RX quality will go down, and because of that you might end up into the drop call. So finding the co-channel interference is most important exercise in the GSM. Okay, so we'll talk about that, how to find this interference, how to overcome this co-channel interference, right? And more about that we will discuss on the next chapter. Thanks.